Hello everyone, my name is Chris Johnson Bidler, and I'm going to give a talk today about Clojure. It's a talk I've given once before, and we'll see if I'm able to do nearly as well this time. So first, a little bit about who I am. I've been doing software development professionally since about 1998. Most of that time I've been working in Java, although I have some C++, some Perl, lots of recent DevOps kind of stuff spattered in there. I grew up in the Twin Cities and I lived there until 2011. I've been living here since then. My wife teaches art history at St. Mary's College. That's why I moved. Right now I'm working for companies in Minneapolis called SPS Commerce, and I work mainly on an AWS Cloud Native workflow engine, translating documents between trading partners in the retail space. So over this last 2 weeks, we did something on the order of 2 million document transactions a day each day. And making that go and making sure it doesn't blow up so terribly when it does blow up that our customers are affected is a big part of my job. I also have an app on the iPhone App Store, and I'm really interested in how apps versus web apps versus command line interfaces work for people, and how you can maybe help people with interface get around perceptual bias or see information in new and interesting ways. Been doing a lot of stuff with Logic Monitor and Sumo Logic at work recently, trying to show people, like, no, this problem is happening at this point in time, and you can see it if you look at this other graph. So, it's kind of fun stuff for me too. So, what is this weird word with a J in the middle of it? Clojure. Clojure is a dialect of Lisp that compiles down to, Clojure is a dialect of Lisp that can be compiled down to JVM bytecode, .NET CLR bytecode, or compiled into JavaScript, including both web-side JavaScript using like Google's Clojure library, and also just straight to Node.js if you want to do Lisp development on a JavaScript stack on the server side, because you can only work well when you do 3 or 4 things at the same time. So why would you want to do this? What do you get from having a Lisp available to you in the JVM world? Well, Lisp has advantages like having functions as first-class citizens of your language, and having also the language be its own abstract syntax tree. Lets you write macros where you can write a function that takes in function code, changes it, and returns a different function as its result. I don't do a lot of writing of macros, but I do a lot of leveraging really good macros that have already been written by people who are smarter than me, and they increase the expressive power of the language considerably. Lisp also is a functional style of language as opposed to object-oriented or imperative, and you can do functional programming in any language, but a language that has it sort of baked in as a set of assumptions from the start makes it harder to do dumb things with functional programming, makes it easier to do things that are powerful. And one of the big advantages that adopting a functional style can give you, if you do it in a smart way, is that your management of state, of data and side effects in your system is separated out from your business logic. So you can make all the assertions you need to make about the behavior of your business logic without ever having to, for example, set up a database first, because all of your interactions with the database are in one place. Your tests for that are in one place. All of your interactions for how different logical things should happen with data traveling through your system is tested in a different way. And another thing that Lisp in particular gives you, over and above some other functional languages, is a read, evaluate, print loop, or the REPL. I hope to show you some of how that works in a few minutes here, but REPL-driven development is incredibly fast. It can be a very nice tool for quickly investigating a problem space, or loading a system up where a bug is and feeding it the data that exhibited the bug, and then trying, well, what if this function did this instead, and just doing it again right at the command line with pretty much instant feedback. It's a very, very awesome way to do software development. I hope that you will also be convinced of this when you see it work in a few minutes. And you also get a lot of the advantages of your host ecosystem because you're running on the JVM or you're running in the CLR, and interop with all of the Java libraries that you use in your Java application is dead simple. It's really easy to get, all of the logging stuff that SLF4j or Logback gives you, or all of the database layer, or ActiveMQ, or whatever tools that you would use in the Java or the .NET ecosystem to get your job done. You can just reach out and take. That's very nice. So what does it ask you to do? What do you have to do to get access to all these cool things that I'm talking about? Well, you do have to be willing to look at things from a slightly different perspective. Functional programming is different than object-oriented programming. It requires you to think about your problems in a slightly different way, and that is a practice that takes time, and you need to, you need to be able to maybe find someone who's solved a similar problem and look at how they did it, or have a mentor to help you sort of get your head around thinking about things in this different way. But once you do, it has some pretty solid advantages. And also Lisp syntax, some people don't like it. I don't think it's that bad. I'll let you judge for yourself when you see it. And as I've said, over and above just the advantages that you get having a functional language and a Lisp, there's a lot of stuff that Clojure specifically has. There's excellent support for concurrency at the language level. There's a lot of stuff is being done, and this slide doesn't talk about it in specific, but there's a lot of stuff being done in the single-page app and web app development world in ClojureScript right now. There's a talk that David Nolan gave a couple of years ago, not a couple of years ago, but 18 months ago, where he stood up something like 10,000 individual worker threads in a browser window without writing a single callback, using something called core.async, which is in Clojure Core and ClojureScript Core. So there's all kinds of really interesting things being done with this. It's sort of at the point where the core work of building the language out has been completed in some aspects, and it's starting to fan out into people finding really cool applications for it. So if you have a problem you want to solve, you can probably find someone, whether it's a web app, or there's a guy named Ramsey Nasser who has used Clojure CLR to talk directly to Unity and is writing procedural 3D games in, writing them in Clojure, seeing them show up in Unity, using, I think his library is called Arcadia. It's gone through a couple of name changes, but right now I believe that's what it's called. It's just a ton of really cool stuff. So you might want to consider looking at Clojure if the stuff that you're trying to do is largely sort of about concurrency. You're doing something like a document workflow engine, or producer consumer. You're taking a bunch of clickstream data and doing business analysis on it in a bunch of different ways without necessarily having to move it from place to place. And if your interrupt needs are amenable. If you're talking to a lot of CLR libraries or a lot of Java libraries already, and if your team is on board. I mean, for example, right now my team is not super on board with the idea of going whole hog into Clojure. So I have a couple of small tools that have been written, but the idea of moving the entire workflow engine is kind of a non-starter because there are senior people on my team who really strongly feel like, well, you can do that in Java, so why would we use something else for it? And you have to kind of work with who you work with, right? You might not want to consider it if you have a really large legacy code base. You might not want to consider just dropping something into the center of it, especially if you haven't thought carefully about how that code base is already factored, and whether you want to do any refactoring, because it's not just a language or a library. It's a slightly different programming paradigm, and so dropping a chunk of that into the middle of something that's a bunch of object-oriented components operating with each other will introduce churn. Another thing that might make you think twice about jumping in and looking at Clojure whole hog is if you're doing something with proprietary binary interfaces to stuff, or your code is already having to reach down into C for performance. Clojure isn't super slow, but it's not going to be able to help you very much there because you're going to have to talk to that C in some way anyway. Or if you have a lot of requirements to interact with things that you don't have a good way to get into one of the virtual machines or languages to which Clojure can be compiled. There are a bunch of places that have had good success with this. I'm not going to talk a lot about it. There are other people's talks in the resources slide of my talk that have more experience because they're at these places. They give better talks about it than I do. But there's a talk from Netflix. There's some stuff from Walmart Labs that talk about strategies that they used for how to consider adopting it or how to get people up to speed with it, and successes that they had, challenges that they faced. If you're interested in this, you think it's something that might be a good fit in your shop or with your team, I highly recommend grabbing this talk off of GitHub and looking at the resources slide. There are some talks there that you might find very helpful. So I'm going to quickly show you what it looks like to code in Clojure, because I really think that I could talk about it for my remaining 10 minutes, and I wouldn't necessarily impart a ton of good information. I think the best way to see what I'm talking about when I talk about REPL-driven development and functional programming is to show you. So what I have here is a small project, and in this project I have an implementation of FizzBuzz in Java and a set of tests for it. And I'm going to show that to you, and then I'm going to implement the same thing in Clojure and show you how it's different. I'm using Emacs for this. The last time I gave this talk I used IntelliJ. There's a really good plugin for Clojure in IntelliJ called Cursive. I don't have IntelliJ on my personal machine and didn't want to bother to download and troubleshoot the install of it, so I'm using Emacs because I have it handy. There we go. Share. So this is FizzBuzz. I assume that you all know FizzBuzz, but I will quickly summarize it. It's sort of a toy algorithm. It's often used in Java interviews. The idea is, given a number, it gives you either that number back, or if the number is divisible by 3, it gives you fizz. If it's divisible by 5, it gives you buzz. If it's divisible by 15, it gives you FizzBuzz. It's not very difficult. You can see it's not a ton of Java. And then there's a main method that runs it. And then there's also I have some pretty simple unit tests, and they basically assert the algorithm that I just described. I'm not going to run them here, although I am going to run the Java itself. So I'm going to start up the REPL. I'm going to point Emacs at a file for which it understands what start up the REPL means, and then I'm going to start up the REPL. And this does take a little bit of time to start up because it is starting the JVM and then loading all of Clojure into the JVM's memory space. So when you are doing REPL-driven development, you often want to start your REPL in the morning, maybe while you're getting some coffee, and then not restart it very often if you can avoid it. So here we are. Do that. Normally I would have that just as part of my startup script, but what that gives you is a bunch of stuff like doc to the function that tells you about other functions, reads the doc strings out of the compiled bytecode and tells you what things do. So I'm first going to just quickly show you what Java interrupt looks like. So I have that FizzBuzz class file already compiled. And now I have access to it. I can, for example, so that just ran the main method, which I suppose I should have it so you can see it. So that just ran the main method, which creates a new FizzBuzz object and then feeds it the numbers from 1 to 101 in a loop. That shows up in the buffer because it's system.out.println, and so that goes to the server buffer, so that you can see it is doing exactly what it says on the tin.
What is the into array? Are you gonna get into that?
Yeah. So into array just takes so in the square brackets is an empty string, and that is a specific type of Clojure data structure. So it has a Java class that is not array of string, and the main method expects an array of string, and so into array just coerces a structure into the Java primitive array. So it's just a little piece of interop sort of syntactic sugar.
What's the dot function?
The dot function is to prevent you from, here, hang on one second, the other way to say this, as it were, would be, like so, which is more of a Clojureism, the idea of calling, because in Clojure you don't have classes, you have namespaces. So you would have a function that exists in a namespace, and you would address it like so. That isn't incredibly idiomatic when you're thinking about calling something on a class, and so there's this other piece of syntactic sugar that lets you call a class, a static function in a Java class in the same way that you would call a function in Clojure, sort of, with a function name in the first position.
For those of us who maybe are a little less familiar, do you mind going through sort of the structure of what's in the parentheses?
Sure, I would be happy to do that.
I've seen it a little bit. But.
So in a Lisp, you don't say like object dot function arguments. You say function name, and everything else after that is the arguments to the function. And that can be also, others. So Lisp stands for List Processing Language. So what you're doing is evaluating the contents of a list. And the first element of the list is the function to invoke with the remainder of the list as the arguments, and they can be nested within each other. So, plus 2, 3, 4, 6. Do I have to import that? Don't. Does that, Rob, does that?
Mm-hmm.
So
I've seen it a little bit, but I want to make sure that
right. So, and I'm about to start writing some code in it, so hopefully we'll get to see a little more of it. There. Here, I want to go look at. So I also have a one test for the Clojure class that I have not yet really started to write. And so this is what a Clojure file looks like. So at the top we have a namespace declaration, which tells you the namespace analogous to a package that the functions declared in this file inhabit. And then underneath you also can have declarations for importing other functions from namespaces that you will use in your functions. And so fact is actually a macro, so it takes the contents of the list form, so everything between those two parentheses, and builds a set of functions out of that and then runs them. And then fact is another macro. Equals is not a macro, that's a function. So what this is basically asserting is the same thing as the first test here. Assert equals, if you do work with JUnit, or I assume that C# unit testing looks very similar. You assert equals that 1 and fizzbuzz.fizzbuzz1 are the same. And here I'm saying I return the supplied argument equals 1 fizzbuzz1. It's a true statement. So let's see what it looks like to run this unit test in a Clojure environment. Here it is. Midja is the name of the testing library I'm using. There is a testing library in the core also called core.test that's very similar to this. In fact, you can pretty much mechanically move tests back and forth between the two syntaxes with a really simple script. However, I don't know off the top of my head the way to do what I'm about to do in Midja in core.test, so I'm using an external library instead. No, not I misspelled it. So Midja REPL gives you a bunch of different things to do with facts. The one that I care about is auto test. I ran the test. It succeeded. You know what's interesting about this test though? It's asserting that when I call that function with an argument of 1, I get back 1. But that's an integer. That's not a string. The Java version gives me back a string. So I really want to say no, and now the test fails. Well, here's my algorithm. It's not very good so far, but how can I get that test to pass most easily? Well, I could return the string representation of the argument instead. And my test is back to passing. And anytime I edit and save a file in either my source tree or my test tree, all the tests that I'm looking at, based on in which namespace I run it, will be run, and I'll get results about what they did and didn't do. So we got a passing test. That's awesome. Let's go think about what else do we want to assert. Probably some of the other things from.
Before you move on, you might have asked you a question.
Sure.
So in the first test, you run the function equals against string 1 and fizzbuzz called with 1.
Yep.
And then you do a fat arrow to true.
Yep.
Is that a shorthand for equals, or is it the same as running the equals function once again outside against true and that, or?
That the fat arrow is a Midja. It's a piece of syntactic sugar that the test library provides. It says the result of this has this nature. You can put true in there, you can put greater than 12, you can put some specific result that you want to see. And one check failed, but one succeeded. My algorithm handles the happy path really well. So, how do we want to deal with this? Well, I'm going to start by showing you sort of the difference between the naive imperative model and how you might look at things instead in a more functional way. So, well, the first thing I want to do, right, is, well, if hey, my test pass. If it's divisible by 3, return fizz. Otherwise, so when you do an if in Clojure, you have the test, and then you have the if path and the else path. The then path and the else path are just the next two forms, the next two lists of stuff. So that was pretty easy. Let's do another one. No, it doesn't work. But now, what are we going to have to do? Well, if it's 3, we want it to be fizz. But then, if it's not, then we have to ask, well, is it divisible by 5? That passes, but doesn't that look ugly? Isn't that going to get to be really horrifyingly difficult to read and pain-inducing to debug if you have more than 2 or 3 cases? Wouldn't it be cool if there was something else that could help us do that in a smarter way? Well, I happen to already know about one, so I'm just going to cheat. Normally, you might have to learn this from someone or spend some time reading the API docs or whatever, but I happen to know that there's a function called Compy. What Compy does is takes in a predicate and then tests against each of the things that are listed after it, and if it's true, return whatever is associated with that and short circuit out. It's kind of like a switch, but not really. And what it would let us do. And so I think that looks like it might work for me, right? But let's see. Let's make sure I understand what I'm going to do with it. So Compy 0. And it returns second. So it looks like I understand. I can play around with it here. In the read evaluate print loop, I can run things. I can stand up objects. I can define. Like say I want to have an instance of the Java FizzBuzz sitting around. And then I can run. Whatever you like. So I can do experimentation over here, and when I'm confident that I understand what I want it to look like, I can go back over here and say, well, okay, so that looks like a much smarter way to handle this situation. I won't put that there. We'll get there in a second. And my tests still pass, but that, I think, is a lot easier to read. And was relatively quick to investigate and find something that I thought would work for me, prove out that I thought it would, that it does work the way I think it does, and incorporate it into code. Try.
Why does a string number equal 0?
It's the default case. If
Oh.
it falls all the way through without having with the predicate hasn't been satisfied by any of the other ones, it will do whatever's last.
Okay, cool.
So the default case doesn't, because in all the previous lines, you have a test predicate followed by a return value.
Mm-hmm.
if there's no return value, it assumes that the only thing there then is the return value instead of the predicate?
It just executes whatever if it falls all the way through the predicates to the last form, it executes the last form.
So if you didn't have string number there, would it just say buzz?
That's an excellent question. I haven't done it that way. Let's see what it does. No matching clause 0. Oh, does string, I bet I know why. Because string 2 returns something that is, I think, because string 2 returns something.
But there's no call to string.
Well, but it failed with an illegal argument exception of no matching clause 0. So it expected to get true, and instead it got an exception. Which actually is a very good question that I am ill-equipped in my adrenaline-fueled state to answer. Oh, I wonder if it's. Well. And then the only other thing I was going to do is add the last test. And I happen to know, because I've done this before, that this isn't going to work. Does anybody know why?
Just calling out of order.
Yes.
It's going to hit the first one.
Yep. There we go. I believe I'm over time. I have given the short coding demo that I wanted to give. Does anybody have other questions or things they would like to know more about? All right. Well, thank you all very much.
Do you have more? You said something about a references
Oh yeah,
and
so
resources slide.
this slide deck is up on GitHub under my GitHub name HLPRMNKY tech share, and I recommend every one of these links. So if you're interested in learning more about Clojure, check them out. Brave Clojure is an excellent introduction to the language. Clojure Applied is a book I'm reading now that's more about, okay, so I understand how to get a web request to work, but I don't know what data structure I should be using for this kind of data that I'm storing or that sort of thing. And then these are some really good talks about successful adoption of Clojure in larger enterprise settings, approaches that they took, and successes and challenges that they faced while doing so. All right. Thank you all very much.
If I take us a couple minutes to switch over here, if anybody needs to grab more to drink, things like that.